Hello, this is part 25 of my preparation for exam NSE4 Fortinet. So now we will continue talking about configuration of IPsec VPN. Phase 1 Network IKE mode config. IKE mode config is similar to DHCP because server assigns network IP addresses, assigns NAT mask and DNS services, similar like DHCP server assigns all these parameters: IP address, NAT mask and DNS settings to its hosts. The assignment takes place over IKE messages. Like DHCP automatically configures VPN client's virtual network settings. By default, FortiClient VPNs use it to retrieve their VPN IP addresses settings from FortiGate. You must enable mode config on both peers. On FortiClient, mode config is enabled by default, but on FortiGate you must manually enable it. To put tick there for mode config. Note that if IKE mode config are displayed on the graphical user interface only when you set remote gateway to dial-up user. On the FortiGate device acting as dial-up client, you can select mode config on the graphical user interface, but additional settings are not displayed. Phase 1 Network NAT traversal NAT-T. ESP encapsulated security payload cannot support NAT network address translation because it has no port numbers. If NAT traversal is set to enable, it detects whether NAT devices exist on the path. If yes, if they exist, both ESP, encapsulated security payload, and IKE use UDP port 4500. It's recommended if initiator or responder is behind network address translation NAT. If NAT traversal is set to forced, ESP, encapsulated security payload, and IKE, Internet Key Exchange, always use UDP port 4500 even there are no NAT devices on the path. Keep alive probes are sent frequently to keep the connection across routers alive. The encapsulated security payload usually has problems crossing devices that are performing network address translation NAT. One of the reasons that the encapsulated security payload doesn't use port numbers like TCP or UDP port numbers. TCP and UDP do, and they cannot differentiate one tunnel from another. To solve this, there is NAT traversal, network address translation traversal, NAT NAT-T. It was added to the IPsec specifications. When NAT traversal is enabled on both ends, peers can detect any NAT device along the path, and if NAT is found, then following occurs on both peers. IKE negotiation switches using UDP port 4500 and ESP packets are encapsulated in UDP port 4500. So if you have two FortiGate devices that perform NAT, network address translation, for example, ISP modems, Internet Service Provider modems, you will probably need to enable this setting. Phase 1, Network Dead Peer Detection. After the peers negotiate the IPsec SAs, security associations of a tunnel, and therefore the tunnel is considered to be up, the peers usually don't negotiate another IPsec SA until it expires. In most cases, the IPsec SA expires every few hours. This means that if there is a network disruption along the path of the tunnel before the IPsec SA expires, the peers will continue to send traffic through the tunnel even though the communication between the sites is disrupted. When you enable DPD, dead peer detection, DPD probes are sent to detect failed or dead tunnel and bring it down before its IPsec SAs expire. This failure detection mechanism is useful when you have multiple redundant paths to the same destination and you want to fail over to a backup connection when the primary connection fails to keep connectivity between the sites up. Dead peer detection DPD is a mechanism to detect a dead tunnel. There are three modes to detect the dead tunnel. Default DPD mode is on demand. DPD probes are sent when there is no inbound traffic, only outbound. Second DPD mode is on idle. DPD probes are sent when there is no traffic. And the third mode is disabled. Only reply to DPD probes, don't send probes. In terms of scalability, on demand is a better option than, for example, on idle. An idle tunnel doesn't necessarily mean that the tunnel is dead. Avoid on idle mode if you have many tunnels because overhead introduced by DPD can be very resource intensive. Phase 1 Authentication. Method. FortiGate supports two authentication methods: pre-shared key, PSK, and signature. When you select pre-shared key, you must configure peers with the same pre-shared key. When you select signature, phase 1 authentication is based on digital certificate signatures. Under this method, The digital signature on the peer is validated by the presence of the CA certificate installed on the other peer. That is, on the local peer, you need to install both the local peer's certificate and the CA certificate that is issued by the remote peer certificate. There are versions, version 1 and 2. They allow you to select the IKE version to use. IKE version 1, Internet Key Exchange version 1 or IKE version 2. When selecting version 2, aggressive and main modes disappear because they don't apply to IKE 2. Modes refers to the IKE version 1 mode. There are two more options available for mode: main mode and aggressive mode. As for aggressive mode, not as secure as main mode. It has faster negotiation, free packets are exchanged, and it requires peer ID check is needed. Main mode, it's more secure. Hash is exchanged encrypted. It's slower negotiation, 6 packets exchanged, and often used when peer ID check is not needed. In aggressive mode, because peer ID information is sent in the first packet, then FortiGate can match the remote peer with the correct dial-up tunnel. The latter is not possible in main mode because the peer ID information is sent in the last packet and after the tunnel has been identified. When both peers know each other's IP addresses or FQDN fully qualified domain names, you may want to see main mode to take advantage of its more secure negotiation. In this case, FortiGate can identify the remote peer by its IP address and as a result associate it with the correct IPsec tunnel. Phase 1 Proposal. Now let's learn about Phase 1 Proposal, section of Phase 1 Configuration of IPsec. This section allows you to enable the different proposals that FortiGate supports. Then negotiating the Internet Key Exchange, Certificate Associations, IKE SA, Phase 1 SA, Security Association. We can combine different parameters to suit our security needs. We must configure at least one combination of encryption and authentication algorithms. First, select encryption algorithm to use for encrypting and decrypting the data, such as AES-256. Select authentication algorithm to use for verifying the integrity and authenticity of the data. SHA-256, SHA-1. Diffie-Hellman groups DH algorithm is used during IKE SA negotiation. The use of Diffie-Hellman DH in Phase 1 is mandatory, and it cannot be disabled. We need to select at least one DH group. The higher the DH group number, the more secure the phase 1 negotiation is. For example, 1 up to 32, the longer is it, the longer computing time. Step 4. Key lifetime on the IKE Internet Key Exchange Security Association. At the end of the lifetime, a new IKE is negotiated in seconds. Local ID. If the peer accepts a specific peer ID, type the same peer ID like IP address or FQDN in this field, local ID. We will continue about phase 1 extended authentication and phase 2 in our next videos.